Hello, my name's Mark and I am G-Code Tutor, and I'm here with Practical Machinist to continue this series where we're programming a part using G-Code on a CNC lathe. So this week we're going to reverse face off the back end of this part. So what we've done so far is we've machined this part complete. We have done all the external and internal parts from the other side. Now we've parted it off, we're just going to face off this back face to get rid of that bad finish from the parting off tool. So let's jump straight into it. So I'm going to start off with an operator's note that just says reverse face, just so the operator knows what this sequence is. When we look through the program, we can see this. And then we come up to our safety line. Now this is arguably the most important line, and I've covered this in great detail in previous lessons. So if you want to know more about how I construct my safety line, pop back to the center drill lesson of this series or many other lessons on Practical Machinist where I cover that topic in great detail. So once we have our safety line there, next thing we're going to do is a tool call. So I'm bringing around tool 1 again. And now we use tool 1 for roughing the main profile. So I'm going to reuse that tool for facing off the back end of our part here. So if you're limited with turret positions, this is a great way to save positions. We can reuse those tools. So tool 01 is our roughing tool, and the second 01 there calls in the information from the datum table, so the machine knows exactly where the cutting edge is of our tool there. And MO6 is our tool change command. So this is going to spin the turret round to put our roughing tool ready to start cutting. We're using constant surface cutting speed on this sequence, so I'm using G50 and S3000. So what this does, it adds a speed clamp. That G50 is a speed clamp command, and it stops the machine from exceeding 3000 RPM. So no matter what happens with our constant surface cutting speed, as we start approaching that center line, the spindle speed is going to accelerate and go up to an infinite speed unless we put a speed clamp here. Now, you may have heard machines in your shop suddenly make a whole lot of noise and speed right up and sound like they're going to blow up. That's because the operator forgot the G50. Okay, so because we're using that G50, as I was saying, we're using constant surface cutting speed, and we turn that on with G96. Now, the G97 in the safety line is our constant spindle speed command, which means that the spindle we set by using RPMs. When we're using constant surface cutting speed, we set it by what feet per minute, surface feet per minute, we wish our material to hit that tool at. So I've added 800 feet per minute here for that spindle speed. Now MO3 turns our spindle on in a clockwise direction. If your tool's upside down, you would need MO4. So now our first rapid command, we're going to move our tool to the start position where we're going to start cutting. So we're bringing in our rapid G-code there, G00, and I'm coming in 50 thou away from the face in Z and 50 thou away from the diameter in X. So we've got a little bit of clearance there. That way we can watch our tool come in and we can know in confidence it's not going to crash because it's not going to be getting too close to any material. At this point, I've also turned on my coolants with MO8. So where our tool is so close now, we're going to do another move, and we're going to move it less than 50 thou there. We're going to move it, what's that, 44 thousandths of an inch to the cutting edge, to the cutting face where we want to start removing material. Now, because this rapid move is so short, I don't want to do it in rapid because it's going to shake the machine. The machine's going to try and speed up to its top speed and de-accelerate in 44 thousandths of an inch. It's not enough room, it's going to do damage to the machine, it's going to hurt the machine, it's going to rattle everything as it quickly jumps from point A to point B. So for small moves like that, I'd rather use a GO1 command and a faster feed rate. That way the machine is still in control, we're in control of the cutter, and everything moves at a speed we can control, not a full-blown, full-out rapid speed. So here I'm moving 6 thou away from that face, using GO1 and a feed rate of 10 thou per revolution of our spindle. With our tool in place, we can now take a cut down that face and start removing materials. So just X 0.2 is fine because I've left that in 0.2 because we have a 1/4 of an inch hole drilled through there at the moment. So if we're coming down to 1/4 of an inch, which is 0.25, this way we're just going slightly into that hole we've drilled. We don't need to go to the center line because there is a hole already there. So with our first cut taken, I'm now rapiding back to a start position again. So we're coming away in X and Z rapid move. So the tool won't scrape over that face we've just machined. It's going to move away at a slight angle, so it's not going to mess up our finish there. So we're coming up at 0.1 over bar size diameter there and 0.1 off the face of the part, ready for our next move. So our next move, what I'm doing here is I'm reverse turning a small chamfer on the very corner there just to remove any burrs. So it's only a very small chamfer, so we're moving our tool -5 thou in Z and 5 thou up on our X diameter there. So the tool's almost touching the parts here. We're only 5 thou away in each diameter and length, but I'm doing that for a reason, because this next line we're switching over to G01 again. We're moving that 5 thou back in Z, so we're on Z0, which is where we want to be for that final cut of that piece there, and we're coming down 10 thou in X. So by 5 thou in Z and 10 thou in X gives us a 45-degree chamfer, and we're going to be taking a 5 thou chamfer off that corner there. So just enough just to break that edge and not leave too much of a visible chamfer. It's purely for a break edge. So I'm also adding a feed rate here of 6/1000 of an inch per rev. So with our little chamfer done and our tool on Z0 now, we can now face off this part. As we're facing down again to X.2, no need to go to the center line because we have a hole there. So with our tool now near the center line, after we've faced off for the second time using a slower feed rate, we can now rapid away using G00. So I'm bringing the tool away 1/2 inch away from that face. I'm also turning off the coolant. Now I just like to add, when we're writing our programs to do something like this, if the part is not the correct size, we don't want to be changing that in the program. We want to be changing our datum shift, our work shift datum, to change the length of that part and not writing the program. So we want to have Z at always 2 inches, and we would change the work shift datum to change the length of the part. So with our tool safely away from that face, we can now send it home with G53. So I'm changing to the machine datum here, which sends it to its home position, X0, Z0, and now that tool is going to go back to its tool change position, ready for the next sequence. So with that done, we can now stop the spindle with M05. We can turn off constant surface cutting speed with G97, puts the machine back into RPM mode, and finally an M01, so we can stop the machine if we need to. So M01 is our optional stop M code there. So M01 now enables us to stop the machine if we wish to check the part. So that's how I would reverse face my part. Now usually we'd have a twin spindle machine and we'd have a transfer from one spindle to another to do this, but because of the way the bar feeders are set up and they're all different and each machine talks to the bar feeder differently, I've not included a transfer between chucks in this series because there's so many different ways to do it and it probably wouldn't be relevant to you. If you want to do transfers between chucks, contact the bar feed manufacturer and see what M codes they use, and they'll give you example programs. So if you want to learn more about G-code programming, computer aided design, computer aided manufacture, machine shop, maths, manual lathe turning, and many other subjects, I have a range of courses over on my website, gcodetutor.com, where you can learn all of this stuff, and there's lots of free articles and things there as well for you. So pop over to gcodetutor.com to continue learning about programming CNC machines.